Hi everyone, this is our first lab session for the Software-Defined Networking Spring 2014 course. And let's start. The first thing you need to do is download this virtual machine image from this link. You can find this link in our homework 1 PDF document. And after you download this virtual machine image, you can load it with your VM player. I will use the VMware. So load it with your VM player and log in with your username, which is mininet. Also, the password is mininet too. So we successfully log into this virtual machine. And the first thing you need to do is run ifconfig, which tells you the IP address of this virtual machine, which is this number. You need to remember this because we want to use our operating system's terminal to remote log into this virtual machine. So we will do, let me make this bigger, SSH mininet, the username and the IP address. Enter the password, which is mininet. And we successfully remote log into this virtual machine. And open another terminal. Remote log into that virtual machine. Again, use the same command. Mininet as password. So we have two terminals which are connected to the virtual machine, and we can do things in our own operating system without typing commands in this virtual machine, which is more efficient. And after this, you can get our Lab1 environment by running a git clone. https github.com sz2425, which is my username, and we have a folder called Lab1. Because I already git clone this folder, so it says already exists. But if this is your first time running this command, it will take a while to download this file. And after you run this git clone command, if you run ls, you will see a new folder called Lab1, here. And let's jump into that folder. Do ls again. You can see we have several files and folders under this Lab1. The first thing we want to let you know is that this virtual machine is already includes the mininet, because this is actually a modified mininet virtual machine. Also, our environment, this Lab1 folder, already includes the Flatlight controller, so you don't have to download it by yourself. And we are focusing on one single file, which is under we can do a vi, which you can use the command to edit the file. The file we want to modify is under source main edu Columbia CS6998 SDN Lab1 called lab1 hub.java. If you can open this file, you can see it's already has some codes there. This is because we try to implement a module called lab1 hub, which implements the floodlight module here. And for now, this hub just do nothing. Whenever a packet get passed in, it will automatically drop it. And one thing I want to know is here, we have an important function called startup here, where we can add some message listener. For now, we only added two. One is packet in message, another is error message. Also, another important function is here called receive. This function takes in a message, and you can, depends on the type of this message, you can call different function to process this message. For example, if this message is a packet-in message, we can call this function to process it. Otherwise, if it's an error, we just print it out. Use log.info. Now let's look at this process packet-in message. I think it's here. This function take in the package, the switch, and some context. For now, this function just do nothing, return continue. That means once the controller get a packet-in message, it will ignore it. That means this package get dropped. Also, we have another function here called write packet out for packet in. This function also takes in the packet in message, but it also takes in the port as the output for this message. So basically, this function sends the message to this output of this switch. I already wrote this function, so you only need to understand it and use it by yourself. You don't need to go through all the details of this function, but just know how it works. So after we take a look at this Java file, under this lab1 folder, we can type ANT to compile that Java file. Build successful. And after you compile it successfully, we can run .floodlight .sh. We can run this script to launch the floodlight. Use the modules defined in that Java file. You can see starting floodlight server here. Also, we can see this Flylight server or controller is listening for the switch connection, because we don't have any network connected to this controller, so it's waiting for the connections. So in another terminal here, we can launch the mininet to set up a virtual network which contains some switches, so that this Flylight controller can control those switches. Here's a useful website called Mininet Walkthrough. You can simply find it under the mininet.org. And here are some tutorials about how you're going to use the Mininet to set up a network you want. You can go through this tutorial and learn something from it. Also, here's another website called the OpenFlow Tutorial. You can find this website from the PDF of Homework 1 in the references here, this one. You can I suggest you go through from the first section to the fourth section, but if you already know something, you can jump to the section 4 directly. It tells us that if we run this command, we can generate a simple network which contains only one switch, but with 3 hosts. Also, the controller will connected to the switch, which is Flylight controller. We already launched that to control this switch. So let's, in the second terminal, copy this command, sudomn topology, single switch with 3 hosts. MAC means we use simple MAC, for example 00001. Also, we use the OpenFlow switch here, and the controller is remote. After you run this command, we will get a network which is exactly the same as this one. We have 1 switch here, 3 hosts. Link from this single switch to 3 hosts. Also, from the first terminal, we can see the controller is not get connected with this switch. So any modules we launched with this controller can do something with this switch. And we have many useful commands for the under this mininet. For example, dump, which dump everything. You can know the host's name here, the switch, the remote controller, and some information, the IP address of this, and the thread number. Also, for a single host, for example h1, we can run h1 ifconfig, which tells you some information about the host 1. You can see the host 1 has a simple MAC address 01. Also this IP address. If we run h2 ifconfig, we can see that h2 has a MAC address 002 and the IP address here. And we want to test. We want to test the connection between the host 2 and the host 2. Host 1 and host 2, sorry. So we can run this command h1 ping H2. We can see the mininet tells us the destination host is unreachable. Why? Because the controller we set up, the modules we are using to configure this controller drops every packet, ignore every packet in. So of course, we cannot ping from the H1 to H2. How can we modify that module, that Java file, to make it possible for H1 to ping H2? We can modify the Java file, but first we need to terminate. The flylight server. You can run Ctrl+C to shut it down, and we can modify that file under source. Modify this lab1 hub Java. Go down all the way to this process pack-in message. We want to do something here to let the switch to let the controller tell the switch which port we need to send for packets from H1 to H2. But first, we need to understand the parameters for this function. For example, this OF packet in message type. How can we know information about this data structure? We have another useful website which provides the API documentations for the OpenFlow Java version. You can find this link again from our homework 1 PDF file, the reference number 4. We can find the OF packet in type here. OF packet in type here. This is so we have one class called OF packet in, which has some properties, but the buffer ID, import, the most importantly, the packet data here. However, we notice that this packet data is an array of byte, which we cannot understand it. But don't worry, we have another data structure called OF match. Under this class, we have one method called load from packet, which take in the packet data we just seen, and the input port for that packet data. All these two information we can get from the OF packet in, which we already take in as a parameter of this process packet in message. So this is simple. The PI, the OF packet in data, has a function called get packet data. We just copy this, put it here. Also, we need another parameter called Oh, I think is this input port, which is the short variable. Also, we can under this OF packaging, we have a function called get import. So just copy it. So we have the packet data and the import, and we want to build it. We want to load the match from these two parameters. But first, we need to define a OF match. We call it a match, new OF match. And after we define this OF match, we can call match load from package. Take in these two parameters, and we get, and we loaded from this package information, and we can get a OF open flow type called OF match. After we set up the OF match, we can call some useful function to get information from that packet. For example, we want to know the MAC address for the source, so which we can call this function get data layer source, which means the MAC address for the source. We can call match dot get data layer source. This function returns a byte. However, we want to convert it to long, so we will write long source MAC equal to Ethernet dot to long to convert this array of byte into a long. Similarly, we can do long destination MAC equal to Ethernet dot to long match dot get. I think is get data layer destination. So now we have the source MAC address and the destination MAC address. Also, you can get other information from the packet by calling functions here. The IP address, I think, is the network destination, which is the IP address for the destination, and some other functions here. But we want to in our case, we want to implement a simple hub which flood every packet so that the H1 can ping H2 by flooding. How can we do that? Notice that we already have one function called write packet out with the out port. If we want to flood this packet, we can send the packet to the broadcast port. But how can we find the value of this broadcast port. Again, we have a function, we have a data structure called OF port, which is the enum. And we have a OFPP flat enum here, which means the broadcast port. We can copy it here. But first, we can call this function. We can copy the function signature here and paste it here. We already know the switch, which is SW, so we can pass it in. Also the packet in message, which name is PI. So we can put PI as the second parameter. The only thing we don't know is the output, but we know is this OFPP flat. So we can write OF port dot OFPP flat. However, this OFPP flat is a type of OF port, but our function takes in a short type. Our function takes in a short type. Again, we need to convert it to short. This is easy because we have another function of this OF port called getValue, which returns a short type. So we take in a packet and write this packet to the flat output, and it should work. The switch should work as a simple hub, flat every packet. And after we modify this file to save it and quit. Also, then under the Lab1 folder, compile it again because we made some changes. And then launch the flight light controller by running this script. This time it says the new switch get connected with this controller, because the mininet, the simple network we set up with mininet, is already existed, so it automatically get connected to this controller. And this time, if we want to ping from the H1 to H2, we can see every package get transmitted. So our simple hub does work. And this is one simple example I want to show you to let you get familiar with our developing environment. and you can, if you have any question about this simple lab session, you can send me email or post it on Piazza. And after this lab session, I want to say more about our homework 1. I think you already have this PDF file from the coursework. So for this homework 1, we want you to implement a learning switch, also a super firewall. We have some specifications for the learning switch requirement and the firewall requirement. You can read through these documents, and if you have any questions, you can send me email or send email to the professor or post it on Piazza. And here are some preparation steps which we already get through some. However, the difference is here you need to git clone another folder called SDN Lab1 instead of our Lab1 folder, and then you can modify the file, modify this Java file after you git clone this folder. Here are some work steps, and some instructions. Also, do remember to run this script after before you hand in your homework. This script will generate an archive which includes the file you modify, and you can upload this archive to the coursework's homework page, so I can download it and test it. Also, we have some hints here and some reference here. You may need to take a look and use and try your best to finish this homework. And I think that's all for today. Thank you for attending this lab session, and feel free to ask questions by sending email to me and the professor. And see you later. Good luck with homework 1.